this session, we're going to be looking at cones, and we're going to be looking at the volume of a cone and the surface area of a cone. And you're probably thinking, how on earth am I going to remember all of these formulae and things like that? And yes, it does take a bit of practice and memory, but there's some relationships between all these structures. So a cone is a very common structure. So this is an outline of a cone. Um, we've all eaten an ice cream out of a cone. For those of you who drive or who go on road trips and things like that, the place is littered with traffic cones all over the place. It's also like a clown's hat and various things. So the cone is very popular a shape. We see it in lots of things around us. But there's a few things to be aware of that if you have a cone like this, and this is the diameter, so D is the diameter of this, H is the height. And if you can imagine that in this cone you have a cylinder of the same base and the same height, well, 3 cones can fit in there. So this gives us a clue. So 3 cones can fit within a cylinder of the same base and height. And so all you need to do is remember the volume of a cylinder. And the volume of a cylinder was pi r squared h. So that's pi r squared and then height. And if that's the volume of a cylinder, knowing that 3 cones can fit within a cylinder, then all you have to do for the volume of a cone is that it's a third. So the formula, you just need to remember this for the cylinder and remember that a cone is a third. So it's a third pi r squared h. And h is the perpendicular. So the perpendicular is a line drawn from the apex all the way to the middle at right angles. Now we're going to go on to have a look at the surface area. So we need to have a look at that diagram. We keep that in view. So this is the volume, it's just a third of the cone. Now let's have a look at the surface area of a cone. Sorry, a third of a cylinder is what I meant. Let's look at the surface area of a cone. So the surface area of a cone is the surface area of the base plus the surface area of the curved bit that goes around. Now from previous videos we know that the surface area of a circle is pi r squared. Then all you need to do is to add on the formula for the surface area of the curved surface, which happens to be pi r L, and this L is not the perpendicular height as we saw earlier, but the length of this slope here. So I don't know how clearly you can see this. This is the height, this is the length of the slope, and this is the radius r. So keep those 2 things in mind. Surface area of the cone, pi r squared plus pi r L. So let's have a look at this in action, in an example. So here we have a cone, and it has a base of diameter 6 centimeters. Now, because we know that's the diameter, and this is the middle bit, then half of it, the radius, well, obviously that's supposed to be an r. The radius is half the diameter, so the radius equals 3 centimeters. The perpendicular height is 4 centimeters, And this line here, the length of the slope is 5 centimetres. Just writing them out larger just in case you can't see those values. So let's start with the volume. So the volume of this is, if you remember, 3 of these can fit into a cylinder. So it's a third pi r squared h. And I always say this when answering a question, write out the formula so you can focus on that. So write that first, then substitute each of these for the actual values. So a third times pi times 3. Now 3 is the radius that we found here, times 4. Okay, and 4 is this perpendicular height. And when you do all the calculations, it comes to 37.7. And because it's a volume, it's got, it's cubed. So 37.7 cubic centimetres, or centimetres to the 3. How about this now for the total surface area? Total surface area is the area of the base, which is pi r squared, plus the area of the surface, the curved surface, pi rl. Let's substitute everything. So there's pi, and we know pi has a value of 3.142. Let's say 3.1. Now it wants the answer to 1 decimal place, so pi can be 3.1 in this case. So it's pi 3.1 multiplied by 3 squared plus pi 3.1 multiplied by 3 multiplied by 5. And if you do the calculation, it comes out to 75.4 centimetres squared. So this is not a volume. Volume is cubed. This is a flat surface area, and so that's squared. What you could do is change the values of these, just as an exercise. This was 4, let's call it 5. Let's call it 5. This is 5, let's call it 6 centimetres. And let's call this 5 centimetres. So we're making only a very small change, but what I'd like you to do is do all these calculations on these new figures and see how close you are, or otherwise to the original figures. So good luck with that.